Bismillahirrahmanirrahim. Welcome to Fundamentals of Engineering Thermodynamics by Michael J. Moran with Dr. Abid Hussain. So in this lecture, we are solving problem 1.5. So problem is as illustrated in figure 1.5. This is figure P1.5. Water for a fire hose is drawn. This is a fire hose. Water for a fire hose is drawn from a pond by a gasoline engine drying pump. This is gasoline engine drying pump. This is blue color. Consider the engine drying pump as a system. Consider engine drying pump. This is a system. This is system, and anything outside the system is surroundings. And this is system. Identify location on the system boundary where the system interact with surroundings and describe events occurring with the system. What is occurring in the system, and the uh, describe the this interaction between system and surrounding. Repeat for enlarged system that include the hose and the nozzle. We will solve this later. So first we consider this as a system, and anything outside nozzle, font, uh, etc. are surroundings. So first, this is intake and this is exit. This is font 1, this is font 2, this is font 2. So 8.1, 8.1, water enter, and 8.2, water exit. So mass enter, it means that mass enter and exit. 8.2, font 1 and font 2 respectively. So there is mass energy interaction between system and surrounding. So there is work energy interaction between system and surrounding 8.1 and font 2. Secondly, per combustion, there is a combustion process in the engine. So per combustion, air enter, air enter, per combustion in air enter into the system, per combustion of fuel, air enter into the system, and hot gases exit from the system, from the system. So there is work energy interaction. Mass enter and exit, so there is work energy interaction between system and surrounding. And third, warm surfaces of the pump. Warm surfaces of the pump. Heat transfer. There is heat transfer. Warm surfaces of the pump interact with surrounding. With surrounding. mean heat transfer between system and surrounding. So heat transfer is work energy interaction. So there is work energy interaction between system and surrounding. So these three cases. Now if we consider this whole as a system, this is system and this is surrounding. For enlarged system, for enlarged system. In this case, nozzle and hose and found are all things are included in the system. So in this case, warm surfaces of the pump and other things in the system, pump etc in the system interact with surrounding, so heat is transferred between system and surrounding. So so this is work energy interaction between system and surrounding. And with this problem 1.5 is completed, and for more videos please like and subscribe my YouTube channel and share with your friends. Thank you.